Our second presentation is again a very exciting one. John Lund from Visy shows us of container video surveillance and artificial intelligence, AI, which could significantly simplify many processes at the container terminal. I'm really excited to learn about that. I know already many ideas for using AI at a container terminal, but the link between AI and video surveillance I have not seen in reality yet. John, I can't wait no longer to learn about that. The floor is yours.
Great. Good morning, good afternoon, and good evening. I think we are live here. I've converted my presentation to a PDF, so there won't be any surprises because we only want surprises on birthdays and holidays. So I'd like to start by thanking all of you for having me here to speak today. My name is John Lund. I'm here to talk about TopView Spreader OCR. And so that you know, some of my colleagues are live in Finland. They're available for chat on the Teams link, which I'm pretty sure is set up through the website. My colleague's name is Iris. You can reach out to her and say hello, and if you have any questions, she'd be happy to help you. So today's presentation actually directly relates to the survey that we took just a short while ago. So the winner of the survey items was quality and speed of port services with a whopping 42%. So my presentation actually addresses just that, so hopefully this is interesting for everybody. So running through the contents for the presentation today, just very briefly tell you about Visy, who we are and what we do. Just talk a little bit about automation at a high level. What is it? How do we view it? What is vision technology and OCR? What's the state of them today? I'll talk about the spreader, which everybody knows from port operations is a pretty critical component. Talk about some of the benefits of creating a smart spreader, and then I'll just wrap it up with a summary. So just very briefly, who are we? Visy. So we specialize in IT solutions for operational automation. Pretty standard solution that we've sold hundreds, if not even thousands of times around the world is the gate operating system. I think everyone's pretty familiar with what the GOS is. It's a piece of mission critical software that monitors everything that goes in or out of your port or terminal, whether it's by key, rail, or road. Over here on the screen, you can see what a damage inspection portal looks like. Essentially, a truck drives through this, and using different technologies, will collect data, such as license plate information, container code, maybe RFID, and some other pieces of information. To give you a sense of the scope of our company, on a daily basis, we manage more than 5 million access and area control events in more than 25 countries around the world. We do have systems in Africa, for example, Tanger Med in Morocco, along with some of the terminals in Egypt. So we're familiar with the African work environment, and very excited to be here, part of this presentation today, to talk with you about what we're doing. So just very briefly, when we're talking about automation, from our perspective, we're talking about collecting data and then sharing that data. And we're talking about operational data. So it's sort of the 5 W's and the H, right? So who's coming into your facility? Is it a driver? What are the security concerns? What are they bringing with them? Is it cargo? Is it a trailer? What is it? Are they there at the right time? So we'll talk about an interface with a vehicle booking system or some kind of appointment system that you might have at your facility. Where? So when this cargo and this individual comes in, where are they allowed to go? There could be different parts of the operation. We want to make sure that the cargo is going to the right place at the right time and not getting lost somewhere in the facility. Why are they there? What is the work order they're fulfilling? And how is this work order getting fulfilled? So typically the VC system will collect all of that data and then share it with a third-party system, such as a TOS, such as an ERP system, such as other operational systems within the terminal. And the desired outcome is scalable, repeatable, predictable, and profitable operations. So in the picture here, you can see a driver kiosk. So that would collect some of the information. The driver enters the facility. They're entering their ID number. They're entering transaction information. so that we can start that process and get them moving on to fulfill their work order. So what is the state of vision technology today? Well, it's a lot more than just standard OCR for container IDs. I think historically, there have only been a few simple pieces of data that OCR would collect, right? So we would have license plates, container codes, maybe trailer IDs, some train information, something like that. But the thrust of this presentation is to talk with you about how OCR and vision technology has dramatically improved over the past 5 years. And there are massive improvements coming, it seems almost daily. So nowadays we're using artificial intelligence and advanced machine learning algorithms to understand the entire environment of what the computer is seeing. And what we see is that this is actually a very effective and efficient tool to collect data to help automate processes. And as you can see here, my blueberry muffin and my dog are apparently twins. Right, so the idea is that the machine vision can actually differentiate between those two things, despite the fact that they look very similar, and it can do it faster than a human. So building on that concept, so we have my little dog and we have my breakfast. Which one is which? Which one should I eat? Which one should I take out for a walk? And in the amount of time that it took a human to go through and differentiate each of those pictures, the computer already did it faster and already shared that data with a third-party system. This technology is truly incredible. It is faster and more efficient than the human eye. So here's a quiz. So what are you looking at? All right, so we have a dog, we have a mop, we have an owl, we have an apple. And you can see that they're very similar. And it might take maybe 1 or 2 seconds for a human to go through and quickly say which one is which. But again, the point of this is that the computer algorithm can do this way faster and with higher accuracy than your average human. This slide just kind of builds on that concept. Honestly, I just love these pictures. The vision technology today is just so advanced that it can determine species of big cats with a high confidence interval. Right? So looking at this picture again, that's a leopard. And the software knows that faster than your eye. So how does this apply to OCR? Well, what we're looking at here are some container codes. And anybody who's been in a terminal knows that container codes are typically in horrible condition. So vision technology traditionally was limited by how terrible those container codes looked. However, these are real container codes that our OCR algorithm, based on the deep neural network, has been able to correctly identify. So you can see that in some of these, it's almost impossible for the human eye to even determine what the code is, yet the software can do it faster and better and more efficiently with less mistakes. And then if we take that vision technology and we extrapolate upon it and we apply it out to a bigger operational requirement at the terminal, then what we have here is a high resolution damage inspection image. So this is the type of image that would be collected in that portal that you saw on the opening slide. So a truck drives through and we take this very high resolution image. So then from an operational standpoint, the question becomes, well, what data is in that image that would be useful for the operation? And the answer is there's actually quite a bit. So we can count the number of axles. We can locate the container corners. We can detect the presence of a seal on the door. We can tell you about the dangerous goods. We can tell you about the direction in which the container is facing. We can tell you whatever other printed information might be on the container or containers, whether it's a tar weight or whatever it could be. We can detect and follow that cargo within the terminal. And very interesting, we can do what's called automatic damage detection. So actually start to tell the operators where there is damage on the cargo or on the goods as they're entering your facility. So as you can see, this is way more than what OCR was even 5 or 10 years ago of just license plate, container code, maybe a trailer ID. Okay, so big quiz. So what is the single piece of equipment on your terminal that is basically involved in every single container move? And then how can we add some of this vision technology to it to make that device smart and help to drive automation? Spoiler alert, the name's in the title. So it's the spreader, right? So the spreader is involved in virtually every container move at your facility. So by adding a very simple hardware and software setup to the spreader, we turn it into a smart spreader. And this is what it looks like. We add a light, we add cameras, we add a device cabinet, we add a very simple PC. And all of a sudden, that spreader knows exactly what it's doing and can share that information automatically, quickly with any third-party system. So essentially, every spreader on your terminal becomes a data collection point. So we're taking images of the box, images of the cargo, and we're also giving you the box ID and the condition of that particular cargo. This is applicable to all container handling equipment. So anything with a spreader. So that's your ship-to-shore crane, your reach stackers, your mobile harbor cranes, straddle carriers, top picks, shuttle carriers, RTGs, ARMGs, whatever it is that has a spreader can be automated with this technology. We automatically confirm the box ID, we match it with the job, we link it to the container handling equipment with a work order, and we send it to a third-party system to confirm what is happening on your terminal in real time. And coming back to the survey that we took not too long ago, again, we're talking about improving the quality and speed of service. So this very simple technology improves all of your operational metrics. I'm going to go down the list. We're talking about reducing the cost per move, reducing truck turnaround times, increasing gross moves per hour, increasing berth moves, increasing your equipment utilization, increasing overall terminal efficiency, and also making it a safer work environment for your people so you have less downtime from injury. Ultimately, we're talking about saving time and money on every single transaction. This picture here off to the side, this is actually what the graphical user interface looks like. So you can see what is happening in real time. You can collect this data. It's saved to your system. It's shared with third-party systems, and everybody knows what's happening on the terminal in real time. So then when we're looking inside of a ship hold, this is what the image would be. So the outstanding part of spreader OCR in terms of ship-to-shore crane operations is that you can prevent wrong moves. So we can verify the box ID while the spreader is actually still inside the ship. So it's not an issue of taking the box out of the ship, bringing it to the quay side and setting it and realizing that the wrong box was moved. You're actually getting the box ID before you even take the box off the ship so that you can prevent wrong moves. This is a huge time and money saver for terminals all around the world. And likewise on the quay side, right? So the spreader is about to pick a box up off the quay, verify that box ID before it even moves. We know what box it is, and the wrong box will not be moved. And then talking about collecting and sharing data. So when we combine the spreader OCR data collection with third-party systems, such as a PDS, for example, you can verify stack integrity throughout the entire yard and always know where your boxes are. So you will never have lost boxes. Every time there is a shuffling procedure, every time there are movements within the stack, spreader OCR, Visy TopView, verifies the box ID. If there's a discrepancy between what the system, between the PDS or TOS thinks the box might be and what our system says it is, then a window pops up and you have an image that shows the actual box ID and you can just manually verify it. There's no better way to look for lost boxes than with this system. So I promised you that I would keep this short, I would keep it relevant. So in summary, TopView turns every single box turns every single spreader into a smart device, and it improves all of your metrics, including speed and quality of operations. Furthermore, it's the only way to automate some Che on your terminals, such as the mobile harbor crane, and maybe some other small top picks and whatnot in your yard. We can go beyond simple box ID for moves and actually integrate with third-party systems to verify stack integrity. And best of all, the foundation already exists on your terminal. You already have plenty of spreaders. Now all you do is have to give them eyeballs to help automate your processes and drive efficiency. Thank you very much. My name is John Lund. You can reach out to me via Teams or some of my colleagues as well. My contact information is here. I'm looking forward to your questions and potentially talking with you soon about how to help you with your operations.
Thank you, John, for this wonderful presentation. It was really exciting. Let's go directly to the questions from the audience. The first question from Lars Greiner. Is there a solution for poor or low networked areas? In many ports, there are blind spots or poor connectivity.
Yeah, so I guess this question is related specifically to the network on the terminal. There are plenty of great network solutions that are out there. I can't think of the companies off the top of my head, but this is a problem that terminals all around the world face, and there are plenty of great solutions out there. I'd be happy to pick that up in a separate conversation. But yes, the short answer is yes, the technology exists and the solutions can be found. And if you email me, I will put you in touch with the right people.
Okay, the second question also from Lars. Does the system give real-time warning?
Real-time warning, I assume that's related to whether or not we're about to pick up the wrong box. And the answer is yes. So if there is a discrepancy between what the work order states that it should be, the box ID should be, and what our system shows the box ID to be, then there's a pop-up, and the user will be able to look at that exception handling. So it was in the software screens, and be able to do a visual verification. So look at the image from our system, look at the work order, compare the two, and do an override if necessary, and if they're authorized. But just to confirm that the correct box is being moved by the correct piece of equipment at the correct time.
Okay, then we have a third question from Gasson Fagayer. It's related to the first question. If the area doesn't cover it by good internet, what's the solution then?
Of course, well, obviously there's a wired solution, but there are a number of different wireless solutions that are out there. Our company doesn't provide them ourselves, so that's a little bit outside of our scope. Normally, we would partner with other companies to do that, and it just depends on the operational environment. So there could be a couple of different companies that we would partner with to do that. And I'd be more than happy to pick that up and make some referrals in an email. But the technology absolutely exists. There are several reputable companies out there who do this, and we partner with them. So that would definitely be part of the solution in case there is poor connectivity.
I have also a question. Artificial intelligence is always about learning from data.
Yep.
If you collect data at one terminal and you learn by these data, can you use these learning exercises for services at other ports?
Absolutely, absolutely. So
this is a question of the background of my question is who's the owner of the data you generated by artificial intelligence?
So our engineers are using images and using data from customer sites, right, to enhance the quality of the algorithms, right? So that's something that's constantly happening. So we might get a data set from terminal 1, data set from terminal 2, and we can combine that data together, in our AI to create our dynamic neural network, right? So that overall, all of our customers benefit from these images that we're collecting at terminals all around the world, right? It only enhances the overall quality of the software and of the algorithms. And there's we're talking about things like box IDs and damage on cargo. So there isn't necessarily any proprietary information or proprietary data that we're taking from customer sites. That's not the issue. The issue is just what data is in an image. What can we extract? How can we make our algorithms better just to automate processes? So we're not interested in a specific terminal's metrics for the purposes of the AI, but rather the quality of the images and what our algorithms can learn from those images.
We have another question from Jörg Gerke. Is the system not very often exposed to damages?
No. So this is a mission critical system, so we have extremely high uptime, right? The cameras that are actually installed on the spreaders are extremely durable. Honestly, historically, that was one of the limitations of it, right? That the cameras or the hardware were not robust enough. I can actually tell you about give you an example from one of our customer sites. So in the Baltic Sea area, where it's extremely cold and icy, we had installed the TopView system on their STS cranes. And then we learned that during the winter, the STS crane operators were actually dropping the spreaders into the water to break the ice around the quay. And we thought for sure, like, wow, our technology is floating away somewhere. It certainly fell off the spreader and it's broken. But when we went and checked the integrity of it, it was all still intact. It was all still working properly, and the read rates were still where they should be. So no, the cameras are actually very small and they're very robust. The equipment is very minimal. It's insulated. It's shock absorbent. So we know what that environment is. We know the type of abuse that a spreader takes, and we have precautions in place to make sure that it works.
Okay. Thank you, John. It was very interesting, your presentation, and thank you for the answers.
Thank you.